It is good day to be not dead.
So yeah, mutations. These are like upgrades both you and the mask can pick up. They grant powerful abilities that change how the game plays. So yeah, this is arc metabolism. Shoots out a fireball that explodes. So you and the mask can attack each other at a distance, like that. Landed a good shot, landed another good shot. And as you can see there, you can use it to like hit the wall, explosion boost, all that fun stuff that we love. Okay, it's getting kind of hard to see. Just restart. Yeah, and then, so yeah, you can attack each other, can boost. The mask can actually use it to break down doors at a distance, which is fun. So can you, I guess, but it's, I don't know, less useful. Let me get in. Come on, buddy, come on, work with me. It broke. Whatever. Yeah, it can break down doors. The player has a variable called toCall. It is an array which holds functions for it to call periodically. The elements of this array are more arrays which hold the function to call, the countdown until that function is called, and another array containing the inputs into that function. This is what the toCall function looks like after the player picks up the arc metabolism mutation. This 2.0 is what counts down, and then the other 2.0 is because it is called every 2 seconds and needs to hold that to reset, or to know what to reset to, and a 0 because it's at the 0 index of the toCall array and needs a way to reference its spot in that array. Metabolisms are area 2Ds that scan layer 4 and 5, which are the layers the player and the mass eyes are in. The eye has this eye tag and its editor description, and when the mutation is triggered, it checks if the thing that picks it up has that eye tag. If it does, it got picked up by the mass and adds it to the toCall jump list in the eye with a 4-jump timer instead of a 2-second timer. If it doesn't, then it got picked up by the player, so it adds it with a 2-second timer into the normal toCall variable. That body.toCall.size is how many other functions are already in the list, meaning it's the address that it's going to have when it gets added to the function list. This is the code. I'm going next. The I mass. The mass is a similar setup, but it's based on amount of time that's lunged instead of time passed. As I said in the arc metabolism script, I might change that to like also have a second timer like the player, but I don't know. That's what it is for now. So this is how the code works. It loops through the toCall jump. Filler 1 is the timer, and so if it's less than 0, that's time to call the function in index 0, using the array at index 2 as the input. It's very similar code, or it's the same code for the player. This is the fireball. There's 2 particle emitters, one for the main fireball body and one for the trail. These are their properties. You want to copy them for yourself. I believe there should be all of them. The fireball itself is in area 2D and has its body and area entered signals connected to this function, but this collided function, but it won't explode until the timer has called A. Fireball signals body entered. You can press pick, and then you can select collided. Where's area entered? Oh, I guess it never connected to area entered. I'll do that now. There you go. All wired up. And then timer. See, the timeout is also connected to A. Well, not also. It is connected to A. And so when collided is triggered, it calls explode. This is the explode function. Notice how it spawns the explosion and the explosion particle separately, because like the other particles, the particle is the child of the main level scene, and not the object it's associated with, so that it doesn't get destroyed when that object is destroyed, as the explosion is rather short-lived, being an explosion. This is the explosion. Not much to it. The timer tells it to kill itself after 0.15 seconds, and until then, if a body or area is in layer 2, which is the hitbox layers inside of it, then it gets hit. Signals, timeout, connected to queue_free. Queue_free is the function that destroys a node. So you'd call node.queueFree to destroy it. So it's calling queue_free in the explosion. The knockback here is just saying get the angle from get to the vector that represents the explosion to the thing that got hit, and then take that angle and then knock it in that direction, basically. So yeah, this is the code, and then I believe that is everything.